we will focus more on process, right? Number one is process. Number one is process. Number two, piston cylinder spring, right? Piston cylinder spring, second question. And third question is piston cylinder stopper. Okay, the first question I focus on process from 1 to 2. 1 to 2, right? And piston cylinder spring. So number 3, piston cylinder stopper. So this concept I have already discussed, right? I discussed already. I explained already. So in the previous class, you know, and process, you know. Piston cylinder spring, this is new, roughly. And if you look the process, for example, this is process is 1 to 2, state 1 to state 2. And piston cylinder spring is something like this. At the top, number 1. Number 2, it might be cooling process, right? I can do like this. It might be number 3. Okay? Different configuration. I can put it. Okay, if you look at my previous year questions, I said for the last 5 years. Okay? And you can see different configuration. And piston cylinder stopper. So this one is quite simple actually. The reason is I can put the stopper either at the top or at the bottom, right? This is one configuration, and another one is here. This is a cooling process, right? Which I discussed in the class already. Okay, this student, nothing new. All right, so now I am going to first question. Question 1, try to understand. A rigid tank. The tank is rigid with the volume of 1.8 times 10 power minus 3 meter cube. It contains water vapor. It contains water vapor at 30 megapascal and 400 degrees Celsius. The rigid tank is now cooled until its temperature is 80 degrees Celsius. Calculate the quality and pressure of the final state. Calculate the total mass of water. Show the process on PV and PV diagram. All right. So take a look. The question tells me this is a rigid tank. This is state 1. State 1 is 30 MPa and 400 degrees Celsius. And I am going to cool down the system. This is the cooling process. Cooling process. And I can see the final temperature is 80 degrees Celsius, right? With liquid plus vapor mixture, right? Liquid plus vapor mixture. So this is the understanding. The question tells me, oh, another one, I forget. The volume, right? The volume is 1.8 given. 330 megapascal and 400 degrees Celsius. What is this? For water. You remember? 400 is higher than critical temperature. Pressure is 30 megapascal is higher than critical pressure. So this is supercritical. Very good. So what I can see from that question, this question tells me total volume 1.8 times 10 power minus 3 meter cube. From here you can see temperature, right? 400 degrees Celsius is higher than critical temperature, which is 373.95, and pressure 30 megapascal, which is higher than critical pressure, which is 22.064 MPa. So what is the nature of the state? Supercritical vapor. All right. So what is the state 2? So first one is state 1, right? So state 1 I can write. Oh, very nice. State 1 I can write. So state 2 tells me the state is found in liquid plus vapor mixture regime, right? Liquid, vapor, mixture, right? So now it is very, very easy to find the quality and pressure of final state. Correct. What is the final state pressure? 80 degrees Celsius, right? What is P2? P saturation with respect to 80 degrees Celsius. Done. And they tell me calculate the quality. Easy. So what is the V1? I can find, right? No problem. So what is the V1? V1 I can find from where? V1 is equivalent to Vg with respect to 30 megapascal and 400 degrees Celsius. And I can get it from table A6, right? From table I can get it. I just plug this value. I know. So secondly, what is V2? V1 and V2 are same, right? Constant volume process. Cooling process here under constant volume because the boundary doesn't change. So V1 and V2 are same. I can say V2, right? So from there I can know V2, right? V2 is okay because I know V1. So what is the final pressure? Final pressure P2, P saturation with respect to 80 degrees Celsius. Correct. Then at state 2, so V2 I know, right? This one I know, this one I can find. So at 80 degrees Celsius I can find Vf and Vg. Agree? From the table you can find at 80 degrees Celsius you can find Vf and Vg. Then you can calculate the quality, right? What should be the quality? Quality tells me X becomes V2 minus Vf, Vg minus Vf. Then I know the quality. Right?
Sir, the V2
V2 is V1.
No, I mean the answer.
Answer I am coming later.
No, 0K or what?
Okay. Okay.
Oh.
This is okay, not 0 Kelvin. Okay, alright. Because V1 and V2 are same. It's alright to you. Okay, I write again for you. V2 becomes V1. Okay? Then you substitute the value of V here, then you can calculate quality. Is also alright. This is also okay.
Okay.
Alright. Then what is the total mass? I know specific volume, I know total volume. What is the mass? Total volume by specific volume, by Archimedes law. Right? So mass becomes total volume by specific volume. I am writing here. What is the mass here? Mass, total volume by specific volume V1. I know. Total volume is given 1.8 times 10 power minus 3 and specific volume I get from the table. Problem is solved. So this is, you understand or not? Understand? Now I am going to show you the solution. This is the solution, right? What is the pressure? Pressure is 30. Temperature is 400. What is the specific volume? 0. This one. Then I can write, what is V1? V1 becomes 0.00278 meter cube per kilogram. Done. Then I need to know what is V2. V2 also same, right? This is equivalent to V2. Right? Then what is the final temperature? Final temperature is 80 degrees Celsius. Am I right? Good. 80 degrees Celsius, what is the saturation pressure? 47.416. So this is the final pressure. What is the final pressure? According to your question, what is the final pressure? Question 1, right? They tell you what is the final pressure. Final pressure P2 is equivalent to 47.416 kilopascal. And another questions they tell you about the quality, right? Quality. Another question is quality, right? Quality X becomes, I tell you, right? B2 minus BF divided by Bg minus Bf. So what is V2? Tell me. V2 is 0.002798 minus what is Vf? Vf is this one. Can you see? 0.001029, right? 0.001029 divided by what? Vg 3.4053, correct? 3.4053 minus 0.001029. What is the answer? Answer I get 0.052%. Multiply by 100, right? Then I can get this value. So this is Vf, this is Vg. So V2 minus Vf and Vg minus Vf by this is the quality. So I can find the quality. My first question is solved, right? So second question, what is the mass? Right? The second questions tell me calculate the total mass of water. So what is the total mass of water? Tell me. Total mass of water. Can I go next? No. No. Can I go next? You can take the picture better. Sorry? Why? Constant volume process. Specific volume also same. Total volume, total mass same, right? For example, this vessel, right? Volume and mass same, right? So specific volume is same. What is specific volume? Total volume by mass. Yes. So they tell me second question B. Second question is B. What is the total mass? Total mass is total volume by specific volume. I have written down the equation. Total volume by specific volume. So total volume is given 1.8 times 10 power minus 3 and specific volume is this guy. then I can get the total mass. Can I go next slide?
The specific volume always be.
Okay, take your time. Don't worry.
我不懂你是用 VF 还是哦，对对。
All right. Okay. So what is the mass? Total mass is volume is 1.8 times 10 power minus 3 divided by 0.002798, right? 2798. And I get the answer 0.643 kilogram. This is the total mass of water. Alright? Done. So now third question. See, can you show the diagram on TV and PV diagram? TV and PV diagram. First I show one is TV, one is PV diagram. Right. First one I show PP, second one is TP diagram. Okay, PV1, I can draw, right? PV1 is constant temperature line. What is the first temperature? 400 degrees Celsius. So this temperature is critical temperature. This temperature is higher than critical temperature. 400. Then I have to draw one temperature higher than critical. And another temperature is 80 degrees Celsius. Then I can solve. So where should be the, okay. So this one indicates the temperature at 400 degrees Celsius. Right? It's something like that. Okay, 400 degrees Celsius. So this one you should draw 400 degrees Celsius. And what is the pressure initial? 30 megapascal, right? So 30 megapascal is higher than, yes, very good, critical point. So this one is 30 megapascal. So this indicates state 1. So what is the state 2? State 2 right? This is state 2. Temperature is 80 degrees Celsius. Right. And what is the final pressure here? What is the final pressure? This one. This one is final pressure I get here. Uh, 47.416, right? 47.416 kilopascal. So this is state 2. So how the process goes? Constant volume process, right? Wow. Okay? So 1 to 2. My drawing is not so good anyway. Ah. Never mind. 1 to 2. So this one indicates V1 and V2 are same. Alright? Similarly, on TP diagram, you must show the constant pressure line. The first one is pressure is higher than critical. So this pressure is 30 megapascal. Right. And another pressure is here, which is 41.416 kilopascal. This pressure is 47.416 kilopascal, and this indicates temperature 80 degrees Celsius. Right, and here it shows 400 degrees Celsius. So this is definitely state 1. And state 2, we just draw a straight line. Right? So this indicates state 2. If you draw one line like that, so this indicates specific volume at 1 and specific volume at 2 are same. Understand? This is the diagram. If you understand this diagram, you can solve the question very easily. Okay? This is state 1, super critical vapor. Temperature is 400, this line, orange. And this indicates 30 megapascal. When you cool down the system, you follow the constant volume process because of rigid vessel. Then you go to state 2. Then at that point, what is the temperature? 80 degrees Celsius, according to the question. And what is the pressure? Saturated pressure with respect to 80 degree, which is 47.416 kilopascal. And this indicates the final pressure. And if you draw one line here, this indicates V1 and V2 are same. Okay? And how you can find the quality? I know the distance from here to here. I know the distance from here to here. Correct. So this distance divided by whole distance. Then I can get the quality. Similarly, I get the same thing. If you draw the TV diagram, saturation liquid, saturation vapor, this indicates the constant pressure line, constant pressure line. Initially pressure is 30 megapascal with temperature of 400. This is state 1. If you cool down the system, it goes constant volume process. V1 and V2 are same. So at that point, pressure is 47.416 kilopascal and temperature is 80 degrees Celsius is given. Right? And how to find the quality? I know the distance from here to here. I know the distance from here to here. Then I can find the quality. Right? V1 or V2 minus Vf with respect to 80 divided by Vg minus Vf with respect to 80 degrees Celsius. Done. Alright? So you have to practice. So next question, I can go. This question tells me a spring-loaded piston cylinder device. This is a spring-loaded piston cylinder device. Is initially filled with 0.1 kilogram of R134 liquid. It contains R134 liquid. Temperature is given, right? Liquid plus vapor, so they're easy for me. I know its initial pressure. I know the temperature minus 34, so initial temperature I know. Right? Initial pressure I know with respect to minus 34. Done. Okay? And whose quality is 80%? Oh, quality is given. So I can find its initial specific volume. Done. So now the spring constant, oh, this is the concept I am coming. The spring constant in the spring force relation is given, which is 6.6 kilonewton per meter, and the piston diameter is 30 centimeter. From here to here is 30 centimeter. Okay, and R134 undergoes a process that increases the volume by 40%. That means if you apply heat to the system, it is moving up, right? Moving up, and the final volume is 40% more than the initial volume. This is the question. Calculate the final pressure and volume of refrigerant. So the answer is given, right? Okay. So now the question is, last time what I teach you, you apply heat and the piston goes like that, right? It's a free moving piston. It's like that, constant pressure process. So now there is a spring here, right? The spring provides extra force. Agree? That's why the pressure is not stated as constant, right? I cannot say this is a constant pressure process, right? Pressure changes, right? And pressure changes with respect to spring distance, right? Which is given by this equation. When x increases, this value also increases, right? Right? When x is 0, no spring force. This is the concept. So, what I can do here? So, at 40, so what is the initial state? State 1 tells me something, right? State 1 tells me 34 degrees Celsius with mixture, right? And quality 8%, 20%, and total mass is 0.1 kilogram is given. Very easy for me now, okay? Why easy? I know the state 1. State 1 tells me temperature is minus 34 degrees Celsius, right? So I can find P1. What is the P1? P saturation with respect to minus 34 degrees Celsius. Agree? No problem. I can get it from the R134 rating. From the table, I can find pressure P1. Right? And they give me the quality. 80% quality. They give me 80% quality. That means I can find its initial specific volume. No problem. Right? Initial specific volume I can find because temperature is given and quality is given. So initial specific volume V1 is equivalent to Vf with respect to minus 34 degrees Celsius plus X quality Vg minus Vf with respect to minus 34 degrees Celsius. Then I can find V1, no problem. Agree? Vg minus Vf with minus 34 degrees Celsius, I write for you. With respect to minus 34 degrees Celsius. Then I can find V1. Correct? So what is the total volume from here to here? I can find, right? Because I know the total mass. Total mass times this specific volume. So I know the total volume. Agree? So I can find total volume, right? Total volume V1 at state 1 is equivalent to total mass is given and times specific volume V1. Right? So I know V1, so I know V2. What is V2? After applying heat, the piston is going up and spring is compressed, right? It travels some distance. Agree? And the volume increases 40%. That means final volume becomes V2 1.4, right? V2. Then I can write final volume V2 V1 plus 40% increase, right? 0.4 V1. Then 1.4 V1. This is V2. So what is the V1? This is V1, right? I plotted this line. This one is V1 and V2, all this volume. This is V2. Understand? So I can find how much distance is traveled by the piston, right? Can I? I can find, right? I know what is the difference in volume, right? So if I draw one line, I say this is the initial state. And this is the state 2. And the delta V is this volume. Agree? So what I do, and I do like this. I say this is state 2 and state 1. If I draw one line from here, I believe this is P1, right? This is the initial position of the piston, right? This is 1. So what is delta V? V2 minus V1. Agree? This area. This volume is V2 minus V1. So how you can find this volume? I know the distance from here to here, right? Right? The distance traveled by the piston, I assume this distance. So this distance times the area of the piston is equivalent to this one, right? Agree? Face area times distance, the cylindrical shape. So that's why I can write, this is the concept. Don't forget, delta V is equivalent to the distance traveled by the piston. I can write delta L. According to this question, delta L times area of the piston. Okay? Area of the piston is the face area. This is the piston, this area, face area. This area is given here. Is given here? Is given, right? Because I know the diameter. So pi by 4 is d square. Is the area of the piston. Okay? Alright, so now you keep in mind. So I am going to the next slide. Alright? So now I am going to the next slide to try to remember what I said. I said, so, okay, remember, I also said area of the piston is pi by 4 dp square. dp is the diameter of the piston. Good. So, what is the state 1? State 1, now I am putting the values. State 1 is saturated liquid vapor mixture at the temperature of minus 34. What is the saturation pressure? 61.56. 61.56 is equivalent to initial pressure. 69.56. This is initial pressure. Because temperature is given at minus 34 degrees Celsius, so initial pressure is this one. Saturation pressure with respect to this temperature. Alright. So now I know the quality. 80%, right? So VF is this one, VG is this one. So I can find quality, right? Is given. Then I can find V1. Specific volume at state 1, I know. Then I know total mass, I know specific volume, I know total initial volume. Then final volume 1.4 times V1. I show you before. So you know, this indicates VF, this indicates VG. Right? Then I know VF, I know VG, I know specific volume at state 1. V1, right? VF, quality is given, and this one is VG, VF, this one specific volume at state 1. And the total volume, M times, this is the total volume, right? Total volume at state 1. State 1, and this one 0.036 6 meter cube. Total volume at state 2. Okay? 0. You just multiply this one with 1.4. This one times 1.4, then you can find 0.03036. Alright? Just multiply. This one is P1 times 1.4, then you can get 0.03036 meter cube. Okay, then I know V1, I know V2, I know delta V, so I can find delta L. Alright. Then what is delta V? V2 minus V1, 1.4 V1 minus V1, 0.4 V1, right? Right. So what is delta V? Delta V is area times delta L. What is area? Pi by 4 dp square times delta L. So this is delta L. Now this indicates delta V. This volume. So I can write delta L becomes 0.4 V1 divided by pi by 4 dp square. Then I can write delta L becomes 0.4 times V1 is 0.021686, right? And pi by 4. What is dp? 30 centimeter, right? 30 centimeter is 0.3 meter square. Alright. From here to here is, what is dp? dp is 30 centimeter, so you should write 0.3 meter. So many students make mistake here. 30, they plug in 30 here, wrong. So you should convert to meter. Very important. All should be SI unit. So length must be in meter. So meter square. Then finally I get delta L becomes 0.1227 meter. Alright. Now listen to the concept. What is the concept here? This is the piston, right? Here is the spring. So piston is moving upward, right? It's moving up, and spring is compressed, right? So spring, the piston travels how much distance? Delta L, right? Correct. And spring is compressed how much? Delta L, right? Because here initially the spring touch here, right? The piston travels this amount of distance, means the spring is compressed by delta L distance. Same thing, right? So what is the spring force? The spring force must be spring constant times delta L. Okay, by law. Spring force is spring constant times distance. So spring force I can write spring constant distance, right? Distance is compression distance, right? Compression distance. Distance due to compression. Okay. What is spring constant? Spring constant is K. K indicates spring constant, and distance due to compression is delta L. So that's why I have written here spring force is delta L is equivalent to K times delta 2. Then what is delta F? Delta P, right? So that means here is P1 initially. When it's moving up, pressure increases, right? So final pressure here is P2. So delta P times area of this piston is spring force also. Right? What is force? Pressure per unit area. Correct. Force per unit area is pressure. Right? this amount of pressure acted this amount of force, for example, this amount of area. So this is the pressure, right? Pressure is 1 or 200 kilopascal acted on this area. This area is, for example, 1 meter square. What is the force? 1 meter square times 200 kilopascal. This is the force. Exactly, I do the same thing. This amount of force is created on this face area. How much force is created or how much pressure is created? Delta P pressure is created, right? On area AP. Understand? That means what I can write? I can write delta P. This amount of pressure is developed on where? Developed on area this. Agree? That's why I can write delta F becomes delta P times area of piston. Exactly. So that's why I just say delta P becomes delta F by area of piston. What is delta F? K times delta L. I substitute the value. What is K? 6.6 kilonewton per meter square. Delta L is 0.1227. AP is 5 by 403 square. Then I find 11.46 kilopascal. This is the delta P. Okay? Agree? Done. Then I can write P2 becomes P1 plus delta P. This amount of pressure is increased. And this is the initial pressure. Initial pressure is, I tell you before, 69.56 times plus. This is the amount of increased pressure. I can write, and this is the final pressure. Done. So this is the final pressure. 81.02 kilopascal. Agree? Done. So what is the final specific volume? V2 total volume by mass. Total volume is 1.4 V1. I substitute the value, I can find this one. 0.3036 meters cube per kilogram. Okay? So this is the final specific volume. So what is the nature of the state? I know pressure, I know volume, then I can calculate final state. Easy for me, right? So how to do final state? I know V2, this value, right? This is V2. So what is the final pressure? 81.02. So at 81.02 kilopascal, I can find VF, right? I can find VG. Then you compare VF and VG with this value. If V2, this one is higher than VF or VG, then superheated vapor. Otherwise, liquid plus vapor mixture. And in that question, answer is superheated vapor. So this one, at 81.02 kilopascal, you have to go table A12, right? You have to go table A12 and you can find VF and VG. Then you have to compare this VG with this value. Compare, right? Then you can find this is superheated vapor. Okay, don't forget. So I am going to the next slide. May I? You understand or not? If you don't understand, practice. Half not good. Alright? So that I do not want to see you next year. Okay? So, you can get it? Okay, so what is the nature? Let's state 2 is here, right? This value and P2 is this value. At this value, at this pressure, we can get P2. Vg is this value, 0.2. So this is smaller than V2. So the state is superheated open. Alright, so now you have to draw PV and TV diagram. This one is important. You should draw. What is PV diagram? This one is PV diagram. Alright. In PV diagram, you have to show. Okay. So now, in PV diagram, you have to show constant temperature line. Right. Constant temperature line. What is the initial temperature? Minus 34, right? Good. So this temperature is minus 34 degrees Celsius. This indicates the initial pressure, 69.56 kilopascal. Right. And initial state is here, right? 80%. This is V1. Then after compression, right? Spring compression is here. This is state 2. Now the question is, why this is looks like an equation, right? Why this way? Why this way? Why? Tell me. Remember, they give you the equation, you see? They tell you F becomes Kx. You remember? Remember this? So what is this equation? Straight line equation, right? And it goes to the origin. So that's why it follows this way. And in that equation, this indicates the slope. Okay, slope of this equation is K, which is 6.6. This is the reason. So I know V1 and V2. So what is the final pressure? This indicates the final pressure. If you draw one line, so this indicates final pressure, which one is 81.02 kilopascal. Similarly, for TV diagram, I should start with the constant pressure line. This is Q1, and this is temperature T1, which is 34 degrees Celsius, minus 34. And pressure P1 I know, and this is T1. P1, and final pressure increases from P1 to P2. So this one is P2, which one is 81.02, right? 81.02 kilopascal. And P1 is 69.56, right? Then it is going this direction. Alright? This is how you can draw the PV and TV diagram. Difficult?
Yes.
Difficult, isn't it?
Yes.
So do practice. Even though you have no time, I know some of you are very busy, but you know, you have to get time, you know. I do not know your workload is how much. It's too high or too low. If your workload is too low, it's okay, you are lucky. Okay? If it's too high, then you know what you can do. If you drive, then you have no time to study, right? So if you go by MRT, then you can read. I saw many students, they read on MRT. They try. You can do this. Okay, when I was a student, I do this kind of method. Okay, even though that time I was full-time student, I never do part-time. I didn't get chance of
Trên này này
paper.
sẽ đi đúng.
Okay, anyway, so life is like that. You have to get your own time. Alright? Okay, so last question. This is the quiz question actually. This is quiz. Something like that.
Yeah.
The piston cylinder device as shown in this figure contains liquid vapor mixture at 3 megapascal with the quality of 60%. At this stage, the piston is resting and enclosed volume
Bao
is
nhiêu ăn?
20 times 10 power minus 3 meter cube. The system is now brought in thermal
No, they are
contact with
bigger.
the heat source of Q. The piston goes up. The piston is going up here, right? Piston is going up and push the stopper. This is the stopper. Push the stopper. Where the final pressure is 6 megapascal. Here is 3 megapascal and here is 6 megapascal. The volume of the final state. Here volume is V1, for example, total volume V1. Here is V3 or V2, which is 2.5 times of initial volume V1. Okay, the volume. Okay, they tell you calculate the mass of water, volume of liquid phase, and gaseous phase separately. You know this. Define the nature of final state and why. Calculate the final temperature. Draw PV diagram and show how the system changes from initial state to final state. Define the location of every state point properly. 1 megapascal is 1000 kilopascal. Okay? This is the question. Okay. In the first question, you can see this is the state 1. I am talking about state 1. In the state 1, this is state 1. I write here 1. State 1. In the state 1, what is the pressure? 3 megapascal. I write P is equal to 3 megapascal. In liquid plus vapor mixture. Then you can find at 3000 megapascal. This is the saturation temperature. This is VF. This is VG. Right? So I can write what is the quality? 60% quality, they say. 60% quality. So what is specific volume at state 1? V1 becomes VF, right? VF plus X times Vg minus VF. So you can substitute the value and finally I get the answer is V1 is 0.06667 meter cube per cube. I substitute the value here. I understand you know the value here. At 3 megapascal is 3000 kilopascal. So, oh, this is the VG. I'm wrong. Sorry. This is not the answer. Okay, the answer is 0.040, right? 0.040487. This is the answer. I give you the answer, okay? And VF and VG you should do by yourself. And what is the total volume at state 1? V1 is given 20, right? 20 times 10 power minus 3 meter cube. So what is the mass? They tell you. The mass of water is, this is question A. Mass becomes V1 by specific volume V1. V1 is 20 times 10 power minus 3. So I can write 0.040487. Then I find total mass is 0.494. 0.494 kilograms. This is the answer. Okay. So now they tell you have to find the mass of liquid and mass of gas. Then how to do it? I know the quality, right? Then I can say, so mass of gaseous phase is quality times total mass, right? The quality is 0.6, 0.494, then I get 0.2964 kilogram, and mass of liquid I get 1 minus x times mt, that means 0.4 times 0.494, I get here 0.1976 kilogram. So what is the volume of gaseous phase? So total volume of gaseous phase G, right? Total volume of gaseous phase is G is equivalent to mg times Vg. Okay, mg I know from here. This is my mg and Vg from here. Then I can find 0.01976 meter cube. This is the gaseous phase, and liquid phase I write for you. Vf is mf, specific volume Vf. So you know mf from here and Vf from here. Then I get the answer 2.40 10 power minus 4 meter cube. I give you the answer. Okay? So this part is very easy. You know how to do. Last week I told you already. Mg, mf also, right? How to calculate mg? Quality times total gas. Mf 1 minus x times mt. Then you have to memorize these two equations. Okay? And I just plug in the value. X is 0.6. Total mass 0.4. Total mass. What is total V? M times specific. Total V, M times specific. Then you can get the answer. So this question you should answer. If you do not answer this question, fail is waiting for you. This question you must answer. And I will give similar type of question. Similar. Same equation.
As quiz.
Yeah. Same equation. But values are different.
What about exam?
Example. Okay. Now question B. Define the nature of the state. So at state 2, you see, so this is state 1. At state 2, it goes up to here, right? At same pressure, correct? 1 to 2 is constant pressure process. Constant pressure. Okay. So what is the specific volume at state 2? V2 becomes, tell me. What is the nature of final state? This is V2, right? And 2 to 3, further addition of V. Right, 2 to 3, constant volume. Constant volume process, right? So, okay, at state, what is the specific volume? V2 becomes 2.5 V1, right? So V1 I know, right? So this one becomes 0.05 meter cube. So what is the specific volume at state 2 and state 3? So this is also equivalent to V3. So I can write specific volume V3 is equivalent to V2 is equivalent to 0.05 divided by total mass, right? 0.494 is equivalent to 0.1012 meter cube per kilogram. Okay, so now you take a look. What is the final pressure? P3, 6 megapascal. Remember, so this is the 6 megapascal. At 6 megapascal, this is the Vf, this is the Vg. Correct. So what we can write? We can write V3 is higher than VA or VG with respect to 6 megapascal. Or I can write V3 is 0.1012 is higher than 0.032449. So the nature of the state is superheated vapor. Okay, so in this question I tell you define the nature of the final state. This is the nature of the final state, superheated vapor. Why? V3 is higher than Vg with respect to 6 megapascal. This is why. If you do not write this, some numbers will be penalized. Okay? You cannot write superheated vapor. You have to define why. V3 is higher than Vg. That's why superheated vapor. Alright, so now what is the final temperature? This is state 3. Never mind, it's okay. Okay, state 3 is this one. State 3 tells me I know V3, right? V3 is 0.1012 and P3, right? P3 is 6 megapascal. So 6 megapascal. So here superheated vapor. And what is V3? V3 is 0. Is here, right? What is 0.101 is here, right? Correct. Vg is here. This value is this one. Right? Then temperature is definitely between 1000 and 100. 1. Then I have to do interpolation. Interpolation tells me T3 minus 1000 divided by 1100 minus 1000 is equivalent to 0.1012 minus 0.097, this one 9756, 0.10543, 0.09756, then T3 I get 1046125 degree Celsius. This is the final temperature. Alright, that's all. Final temperature I give you. It's not a difficult question. If you understand properly, this is very, very simple. Alright? Any question? Understand is important. First one, 1 to 2, constant pressure, 2 to 3, constant volume. When constant volume, pressure becomes 6 megapascal. But volume is same, right? Then I go to the superheated table. The volume is found between 1000 and 1100. Then I do interpolation. I can find final temperature. That's all. Now you have to show the process on PV diagram, right? Which diagram I should tell you to do? PV and PV diagram, right?
Yeah.
Okay.
People finish the paper, I just special.
I take only 5 minutes. This
5 minutes.
is the last.
See how bad the question is.
Okay? I spend here more time for you. So you should be good result, right? Okay? I spend more time, you should be good result.
It's not next week, right?
Next week.
Oh, not next week, right?
Next week is your
Alright. Alright, you can see in PV diagram diagram,
IVC,
I draw constant temperature line. This one is temperature T1, right? And P1 is here, I know from the table. And what is the initial state? Initial state is 60% quality, right? So this is state 1. So this one is V1. And what is the final temperature? I do not know, right? At the moment. Final temperature is 10 something, right? So this is definitely something like that. So this is the final temperature. T3 is 1046, right? 1046.25 degrees Celsius is here somewhere. And this is temperature T2, right? T2. We assume this is T2. So when temperature is increased, it goes from 1 to 2. Like that, right? This is state 2. V2, right? So when you apply more heat, constant volume process, right? So it goes from 2 to 3. All right. Okay, this is the answer. Secondly, if you draw TV diagram, I focus on initial pressure, right? Initial pressure is 3 megapascal. You remember? This is T1 is 3 megapascal. So this is the initial temperature T1, right? And this is the initial specific volume. This is state 1. When you apply heat to the system, it follows constant pressure process, right? Constant pressure process, I can draw here. So this indicates P2. And after that, you see the temperature increases, right? Up to 6 megapascal, right? So this indicates 6 megapascal, which is P3. Then process goes from 1 to 2, something like this, right? 2 to 3. Now it looks very nice, actually. Perfect. So, what is the temperature? You have to go more, right? Otherwise, you cannot go. So this indicates
1046.2.
yes, very high, right?
Very high,
And this temperature is nearly 400, right?
yeah.
So you have to draw like this.
So next week, I mean the quiz only 1 question.
Two questions.
So one question.
One question everybody can answer. Another question you have to choose.
Another question everybody can answer.
Alright? Understand? Yeah, right one.
Don't understand another question.
什么玩？
好尴尬。
The V1 to V2 starter.
Yeah.
Why based on the equation?
Because that's the additional thing. If got nothing, then it's still free.
If nothing is like that lah.
Nothing is
If it's
constant.
constant, it's like that lah.
Yeah.
Then if
Then that's why
something
got
then
the extra. Then got extra pressure. Then the pressure increase. It's not constant like that. If the pressure increase, then it will go like that.
depends on what equation.
Depends on the whatever
If it's
equation
a
it is.
linear equation means it's straight lah.
Yeah.
If it's something else,
Yeah.